In 2019, a conservation group let 5,000 bison loose on 150,000 acres of Texas that had basically stopped working. The soil was hard as brick, the grass was gone, and the plan was to check back in about 50 years. They got their answer in less than 2. Within 18 months, the ground cover had roughly doubled. Streams that had been dry for decades started running again, and the satellite readings got flagged as an error because nobody believed land could come back that fast. Here's what the bison actually did to the dirt. I'm Ambrose Wild, and the strangest part of this story is that the bison were not the first animal to redesign that land. They were the second. Because to understand why the recovery moved that fast, you have to understand that the desert was never natural. Survey records from the 1870s describe the Southern Plains as some of the best grazing country on the continent, with deep soil and grass standing knee-high to the horizon. Then came the cattle, and within about 60 years, that country was thorn scrub and blowing dust. Cattle are selective grazers. Turned out on open range, they find the most nutritious grass available and crop it down to the crown. Come back and do it to the same plants again while walking past the tough woody stuff. Do that for a few decades and you have not just removed the good grass, you have handed the ground to everything the cattle refuse to eat. But the part left out of almost every version of this story is that the cattle did not merely fail to stop the mesquite, they planted it. Mesquite pods are sweet and cattle eat them by the mouthful. Seeds have a hard shell that survives the trip through a cow, and they come out the other end scratched open, ready to sprout, wrapped in a warm pile of fertilizer and dropped wherever that animal happened to wander. Ranchers spent 100 years fighting mesquite with bulldozers, chains and herbicide, while their own herds were seeding it across millions of acres of Texas rangeland. The trees they were paying to remove were arriving by delivery service. And mesquite does not share. It drives a taproot far below where grass roots can follow and drinks water the grass will never reach. 2 things had held mesquite in check on these plains for thousands of years. By the middle of the last century, we had removed both. Hold on to that because it comes back at the end. The soil went next, and the way it failed is worth picturing properly. Raindrops hit bare dirt at around 20 miles an hour. That impact shatters the loose crumbs at the surface into fine particles, which settle into the gaps and dry into a sealed crust. The next storm runs off that crust the way it runs off a parking lot. So the water table underneath West Texas dropped. And it was not because less rain fell. It was because less of the rain that fell ever got in. That is what the bison walked into in 2019. The problem was never really the rainfall. Another animal had spent a century assembling this, one hoofprint at a time. So what does a bison do that a cow does not? The first difference runs backwards from what most people expect. Bison are not indiscriminate eaters. They are grass specialists, and grass and sedge make up the overwhelming majority of what they consume. They walk right past the broadleaf wildflowers. Cattle eat those wildflowers readily. Which means on bison range, the flowering plants survive the grazing season intact. And that is the real reason the bees and the butterflies came back in numbers that startled people. The bison were not feeding the pollinators, they were simply declining to eat their food. The second difference is that a bison grazes while walking. The herd takes a bite and moves, covering ground constantly, and it rarely comes back to the same patch twice in one season. Cattle are homebodies. They find shade and water and they settle in, which is why creek banks on overgrazed range look chewed into mud. Bison drink, and leave. Therefore, within 2 seasons, those stream banks had plants holding them together again, and a vegetated bank keeps water moving in the channel instead of letting it cut down and drain away. That is most of the mystery behind the creeks that started running. But the most consequential thing the herd did involved no eating at all. It happened when they lay down and rolled. Bison wallow. They drop onto a shoulder and grind themselves into the dirt to shed insects, shed winter hair, and cool off. And a 2,000-pound animal doing that leaves a bare, compacted bowl in the ground, 10 to 15 feet across. 5,000 animals doing it daily leave the ground stippled with thousands of these bowls. Here is why that matters. The floor of a wallow is packed hard, so it does not drain. After a heavy rain, every wallow becomes a temporary pond that holds water for days or weeks in country that otherwise sheds it. Spadefoot toads spend most of the year buried underground, waiting for exactly that signal. They surface after a storm, breed in those short-lived pools, and their tadpoles race through development before the water is gone. Invertebrates colonize them, and different plants ring the rim than grow on the flat. And wallows do not vanish. Researchers have identified wallow scars more than a century after the last bison left, still readable in the soil chemistry and still visible from the air. What the herd builds in the dirt outlasts the herd by generations. There is also what comes out of them. A herd that size drops an enormous volume of dung, and on healthy ground it does not sit there. Dung beetles locate a fresh pat within minutes and bury it, dragging nitrogen and organic matter down into soil that had almost none left. On heavily treated cattle range, those beetles are often missing, because common livestock dewormers pass straight through and kill whatever tries to process the result. Then there is the delivery problem, because seeds have to come from somewhere. A bison coat is a mess of coarse hair that catches seed heads and carries them for miles before they work loose. More seed rides through the gut and lands in dung. So the herd doubles as a distribution network, moving native plant material across 150,000 acres in a pattern no seed drill could copy. The prairie did not wake up on its own. Most of it was carried back in, a few seeds at a time, on the backs of the animals that used to live there. By year 2, the surveys were finding something the team had not written into any of their models. The recovered ground was not uniform. It was patchy, and the patchiness was the point. Bison graze hard in some places and not at all in others. So you get short-cropped lawns sitting right against stands of tall, ungrazed cover. To a person, that looks untidy. To a bird, it is the difference between a place to live and a place to die. Some grassland birds nest only in bare or short ground. Others need deep cover to hide a nest. A uniformly grazed pasture offers exactly one option, which is why grassland birds have taken the steepest population losses of any bird group in North America. A bison mosaic offers a dozen options inside a single square mile. And this is not a 2-year fluke that got lucky with the weather. At Konza Prairie in Kansas, researchers have run the same comparison for more than 3 decades. Ground grazed by bison ended up with roughly double the native plant species of ungrazed prairie. Cattle produced a smaller gain than bison did, and the bison plots held their diversity through the worst drought in the record. The Texas project moved fast. The Kansas data says it should also last. If this is the kind of thing you want more of, subscribe, because I go looking for the mechanism underneath the headline every week. Now, back to those two things that used to hold mesquite in check, because this is where the story turns on itself. Bison were one of them. Bison browse mesquite seedlings and trample young growth, and against a first-year sprout that works. Against an established mesquite with a trunk and a root system, it does almost nothing. A herd will not remove a mature thicket. Anyone who tells you 5,000 bison cleared the brush is selling you half a mechanism. The other one was fire. The southern plains burned regularly from lightning and from fires set deliberately by indigenous nations who understood exactly what the burning did. Fire kills mesquite seedlings outright and knocks mature trees back to the ground. Grass, with its growing point at soil level and its energy stored underground, shrugs and regrows within weeks. And here is the part that makes the two work as one machine. Bison actively seek out freshly burned ground, because the regrowth after a fire is younger, greener, and higher in nitrogen. So the herd concentrates on the burn, grazes it hard, and leaves the unburned ground alone to grow tall. Next season, a different patch burns, and the herd follows. Burn, graze, rest, repeat, moving around the range on its own schedule. That is what built the mosaic in the first place. Fire chooses where the herd goes, the herd decides how hard that patch gets hit, and the untouched ground gets years off. We removed the fire, fenced the animals, replaced them with a species that stands still, and then we blamed the grass for dying. So the honest headline is not that bison fixed a desert. It is that bison and fire are two halves of one system, and Texas finally ran it with both halves installed. What the recovery unlocks underground is the reason any of this matters past the fence line. Prairie is essentially an upside-down forest. The visible grass is a fraction of the plant. The real structure runs 10 or 15 feet down as root, built almost entirely from carbon the plant pulled out of the air. It stays down there. When a forest burns, the carbon in the trunks goes back into the sky within days. When a prairie burns, the carbon in the roots does not care. Fire seasons keep getting longer nearly everywhere, and carbon parked underground is carbon that stays put. The Great Plains covers something close to 500 million acres, and a large share of it is in rough shape for exactly these reasons. The arithmetic of scaling this up gets run constantly. But the wall here has nothing to do with biology. It is fences. This worked on 150,000 acres because the animals could keep moving, keep grazing unevenly, and keep leaving ground alone for months. Put bison behind tight fencing on 40 acres and you have not restored anything. You have got a cow with a hump. The room is what does the work, and the animal can only use the room it is given. That is the uncomfortable thing this project proved. We already know the fix and have known it for a century. The only thing in the way is how the land is divided and who it feeds. The bison were never the miracle. They were just the part we could put back first. If you want more of these, the ones where the boring mechanism turns out to be the entire story, that is what this channel does every week. And there is another one ready for you right now. I'm Ambrose Wild.